All right, so we're just talking through the extra wave math problems key here. Um, so I put in a lot of information already. I'll talk through where it comes from, but just saving a little time typing here. So I'm going to actually draw a lot on this one. So what we have here, equation for wave speed. Wave speed is v. You also see VW for wave speed. Frequency is f. Wavelength is lambda. Units, wave speed, meters per second. Frequency is hertz, and wavelength is meters. Now, if I wanted to put this into a triangle, when these two are multiplied, that's really what happens here is you see it go like this, right? The things that are multiplied go on bottom, and then the v you want goes on top. So that's what I see right here. So I'm going to undo that quick, just so you can see where that comes from. So if you don't remember that, you can certainly always put them into the triangle yourselves. So if the frequency of wave is 440 hertz, so I know that's one of my givens, frequency is 440 hertz, so always write down your givens. What is the speed of the wave, which is v? And I already know my answer will be in meters per second. If the wavelength, lambda, is 3.2 meters. Okay, so now what I know is that v is equal to, and if I'm using a triangle I covered up, it's frequency times lambda, or it's listed right here. So it's frequency f times lambda, and then I'm just plugging in what I know, which is frequency for 40 hertz. Sorry, this is taking a really long time. Times wavelength, which is 3.2 meters, which is then equal to, get my math going here, 440 times 3.2 gives me 1,408. And it's wave speed, so that would be meters per second. That's pretty fast. I'm going to try to save some time here and just type instead. So next one, I got wavelength is 0.5 meters. It's moving at 15 meters per second. What's the frequency? So I go up to my triangle. Frequency covered up is equal to v divided by lambda. Okay. So f is equal to v divided by lambda. Oh, that's not right. There we go. V divided by lambda. So then I plug in what I got. 15 meters per second divided by 0.5 meters. Why does he keep adding these? Gives me 30 hertz as my frequency. So the label you'll have to pick out based on I'm solving for frequency. You know, when we did a lot of the speed stuff, seconds cancels out, I'm left with meters. Here, meters cancels out, I'm left with seconds, or it's meters over per second, I know what it is, but for this it's a little bit tougher. Okay. Now, same thing here with frequency and period. F is equal to 1 over t. I can literally just draw that out by, let's go here. So F is equal to what's on top 1, what's down here, period. Now, it doesn't matter which one you chose because both f and t would be on the bottom and 1 would be on the top both times. So whatever variable I'm covering for, I can cover it up. If I want f covered up, 1 divided by t. Want period, 1 divided by frequency. And that's how you can make your triangle for that one. Okay, so now the good news is these ones are just pretty simple math. So frequency is equal to 1 divided by period, which is equal to 1 divided by 0.75 seconds, which is equal to 1.3 if my math is right. 1.3 repeating, yep, 1.3, and it's frequency, so it's hertz. Okay. Same thing here, I want period this time, so covered up, it's 1 divided by frequency, so t is equal to 1 divided by, that's an I, 1 divided by f, which is equal to 1 divided by 250 hertz, so I should get a pretty small number. 1 divided by 250 gives me 0.004, and it's period, so seconds is my units. Okay. And last 3 questions. Mechanical waves, like sound waves require a medium. Electromagnetic waves, like light, do not require a medium. If I'm measuring period, I'm measuring the time per cycle. If I'm measuring frequency, I'm measuring the number of wavelengths per second. So 250 hertz tells me that I get 250 wavelengths that pass a same point over and over again within 1 second. Okay, so that's our extra wave review problems. Let me know if you got any questions.